Hello everyone, welcome to another MCAT ACE lecture, and in today's lecture we are going to be talking about chemical equilibrium. So a general outline as far as what we're going to discuss here. We will first talk about equilibrium theory and concepts. So what does it mean for a reaction to be in equilibrium? What are the requirements? And we'll also take a look at units for equilibrium. Then we'll discuss the equilibrium constant, and we will look at how to actually calculate it, the equation we would need in order to come up with an equilibrium constant. We'll briefly discuss the role of temperature, because temperature is one of the only things that can change the equilibrium constant itself. We will take a look at some sample calculations on how to calculate an equilibrium constant, and then we will briefly talk about the omission of solids and liquids, because a lot of times when we get ready to do these equilibrium calculations, we will typically drop out any solid or liquid states of matter, and that's just because their concentrations seem to be overwhelming in comparison to that of the aqueous forms or the gaseous forms. Then we'll take a look at predicting the direction for reactions. This is probably the type of thing you're most used to if you've gone through a general chemistry course, where we will look at the reaction quotient and compare it to the equilibrium quotient or the equilibrium constant. And when you compare those two, you can determine whether you will favor the reactants or the products at a given time period. Then we'll also take a look at finding concentrations at equilibrium. Now, this is the typical, what they would call an ICE box, ICE, where ICE stands for the initial concentrations, the change in concentrations is the C, and then the E is equilibrium. So you may remember setting up ICE calculations or ICE boxes or things like that in your general chemistry course. They may have been referred to as something else, but we'll take a look at that. We'll look at the general premise of it. You can get into more complicated versions where you have to pull out the quadratic formula depending on the way the equilibrium concentrations are set up. So we'll note that when we get there. Then we'll discuss the theory of Le Chatelier's principle. So we're already looking at Le Chatelier's principle mathematically speaking in the higher portions of this outline. So at the end we will formally discuss Le Chatelier's principle and what happens if I, change the temperature, what happens if I change the pressure, what happens if I change the concentration of either reactant or product, what could I expect as far as the shift in the equilibrium positioning. And then, as usual, we'll have the practice and the summary. So, let's go ahead and get started in our first part of the discussion for chemical equilibrium.